Hi guys, welcome back. In this video, we are going to proceed with the first subtopic, 2.1 Introduction, and part of 2.2, which is the basic concept of probability. So let us start. In Chapter 1, a descriptive statistic is introduced as a method or ways for organizing, summarizing, and presenting data. Data can be presented either graphically or numerically. The simple idea of Chapter 1 is how to make sense of data collected. In this chapter, we may start with an idea about how to measure uncertainty, since there are events with unpredictable outcomes. Therefore, theory of probability will help us with such problem. In this chapter, basic concept of probability will be introduced and several applications of probability will be discussed. First, let us be clear. What is probability? Back then, we know probability talks about measuring uncertainty. However, the formal definition of it is probability is a numerical description of a chance of an event to occur. It is quantified as a number between 0 and 1 only. It cannot be less than 0. The value cannot be more than 1. Probability concept is important in many real applications, such as in reliability engineering, sciences, insurance, and economics. In most applications, probability models are used in risk assessment. For example, you may ask, what is the probability of a machine will produce defective items during the warranty period? We may also ask, what is the chance of surviving in an operation or having a particular disease? We might also be wonder, what is the chance of a person aged 30 years will die in the next 5 years? We can also ask, what is the probability of 15 customers to arrive at a bank in the next hour? All of these questions involve uncertainty that can be answered by probability. The theory of probability is the foundation to statistical inference, which we are going to cover in the next topic. In statistical inference, a conclusion about population is drawn from simple information. Sample information, for example, the sample mean differs sample to sample due to sampling variability. Therefore, probability distribution allows us to make a statement about a random variable. This section begins with some definitions and basic concept of probability, which is in subtopic 2.2 later. Then after that, the types of probability and probability rules are discussed in the next video. And after that, applications of two discrete probability distributions known as binomial and Poisson probability distribution, and later continuous probability distribution, which is normal and later being converted into standard normal probability distribution, will be illustrated. Now let's go to the second subtopic, which is basic concept of probability. Let's try to answer, why probability? Why do you need to have the knowledge of probability? Among the use, we can use it to quantify likelihood or chance of an event. By event, I mean any situation that you want to quantify. We can also use it to calculate uncertainty or risk in engineering. Alright, probability can also be interpreted as long-term relative frequency or a degree of belief. Now, let us define several important terms required in understanding the concept of probability. Okay, let us look at the first one. We have random experiment. What is random experiment? It is an experiment which is a process or activity where all of the possible outcomes cannot be predicted or uncertain ahead of time. Hence, random. The simplest example of random experiments that always being used in statistics is flipping a coin, rolling a die, or drawing a card from a deck. Next, we also have an outcome. The term outcome means a possible result of an experiment. For example, head is one of the possible outcomes when you flip a coin. Right? When you roll a die, 5 is among the possible outcomes. So that is outcome. Right? Let's look at the next term. We have an event. Event in statistics means outcome or outcomes of a process, which is activity and experiment, whose probability is being calculated. Right? You can assume event here, right, as a situation that you want to look at. Right? For example, you might want to later find a probability of getting head when flipping a coin once. So the situation of getting head is the event. Or you might want to get odd number when you roll 2 die. Right? So that is kind of things that we call event. And if you realize, I did mention that event is an outcome or outcomes. We have plural and singular terms there. So an event with one outcome is called a simple event. Right? However, if you have an event that consists of several outcomes, or we can say several simple events, we are going to say that it is a compound event. Right? For example, the event of getting an odd number when a die is rolled. Right? We have 3 outcomes. So, or 3 simple events. So, it is called compound event. In general, a compound event consists of 2 or more outcomes of simple event. Right? Another terms that you're going to learn is sample space. Event is a subset of sample space. So what is sample space? Sample space is defined as the set of all possible outcomes. All. For example, when you are taught flipping a coin once, the sample space of all possible outcomes are head and tail. 2 outcomes. When you roll a die once, all of the possible outcomes will be 1, 2, 3, 4, 5, and 6, of course. Those are called sample space. Okay? There's a lot of other things that we can look, right, and find out the sample space. For example, if you want to select a student, based on gender, what will be the sample space? Of course, it can be either male or female. Right? If you are kicking a penalty, what can it be? You can either get it into a goal or miss it. Also hit and miss. If you're answering a question of true and false, the sample space can be true or false. If you are tossing coins, but now 2 coins, it will not be head and tail anymore, because 2 coins will have more combination. So you can have either head or head, tail or tail, head or tail, tail or head.
Audiohub preview.
Right? So it is actually important to realize regarding the 2 coins before. Right? When you are tossing more than 1 coin, the sample space increase. The same goes when you tossing more than 2 coins. So actually the sample space will keep increasing as the combination increase. So how do we find the sample space easily when it comes to several combinations so that we don't miss it? We can use tree diagram. Okay, we have tree diagram to illustrate experiment and list out all of possible outcomes. Okay, so the method used to calculate probability of any event is depend actually on the types of probability that we're going to discuss later. Okay, there are actually 3 types of probability, which is classical, empirical, and subjective probability. However, in our textbook, we are going to discuss only classical and empirical probabilities. Okay, the other name for empirical probabilities is experimental probabilities. Okay, so let us try to, with all of the terms maybe being cleared, let's try to discuss this example. We have example 2.1 in your book. Okay, so a family has 3 children, right? But we don't know their gender. However, we can assume that boy is as likely as a girl at each birth. Right? For the first child, second and third, their gender is actually likely. So they can be boy and girl. The possibility is 50-50, right, as we say. So with that information, what is the sample space for the gender of the children in the family? So we have 3 children. So basically we want to find out the combination of those 3 children, right? Because their possibility is almost likely. So we can say that no, you have boy. All of the children might be all boys, all girls. You might have 1 boy as the first child, and then 2 girls for the second and third childs. Right? We have several combinations. So the correct way to find the sample space, as I have said before, is by using tree diagram. So this is tree diagram. And let's see how do we find it out. So first, let's try to find the possibility of gender for the first child. So this is how you draw it, right? And then so basically you have either the gender is actually either boy or girl, right? So now that we have figured that out, now let's proceed to the second child. So it can also be either boy or girl. So how do you draw the diagram? You are going to proceed, right, from the branch of the first child, right? You continue for the second child. So you are going to have this kind of branches. After that, we are going to look for the third child. So as you may guess, we are going to continue drawing the branch of the
Audiohub preview.
third child from the second child branches. Okay, if there is maybe the fourth child and the fifth child, the tree diagram, right, will be expanding even further and will be bigger. So now, by using this tree diagram, how do we figure out the sample space? Just by looking at the combination at each branches. So for example, for the first branches, we have boy,
Audiohub
boy,
preview.
and boy as our first combination of possibility. And then for the second one, it is boy, boy, and girl. Right? Just look at each branches and you will find the correct combination without any miss.
Audiohub.
So you will have all of the sample space there. So all in all, we can see that we have 8 possible combinations. How do we know it's 8? Just count the number of branches that you have at the end. So that is in terms of tree diagram. Now that you have all of this information, the way to write it down, the correct way to write it down in statistic is like this. You need to put capital S as the notation of sample space, equal to curly bracket, and input all of the possible combination of sample space there. That will be the answer for the sample space. Now let's look at the second one. For the second question, we have an event. They want us to define an event or a situation where the family is having one boy in the family. So we denote event as capital E. Now, what is the possibility of having one boy in the family? So we can just simply look back at our tree diagram, or we can just simply look at our sample space and find out which of the combination that have only one boy. So we have girl, and boy, the combination of girl, and boy there. Right? We have also a combination of girl, boy, girl, and we also have boy, girl. Other than that, it is not one boy. So basically, for this event, right, which is the event of having one boy in the family, we have three possible combinations. So that is how you write it down: E equal to curly bracket with all of the possible outcome. So that is for this subtopic. Alright, in the next video we're going to talk about types of probability. Right? See you. Thank you.